Hello everyone, I'm Morgan Jack. I'm now Senior Inside Sales at Restrictive Technologies. Today I will show you how to answer acoustic needs in the heavy equipment industry thanks to acoustic simulations with the Actran software suite. So if we get a look at the agenda of this webinar, above all I will say a few words on why acoustic simulation is interesting for construction and agricultural machineries. And then, very briefly, I will present you our Actran software. In the second part, which is the main part of this webinar, I will talk about noise sources present in the heavy equipment industry, how to reduce the noise and how to do it with Actran. Then I will address acoustic standards and how to model them in Actran, and it will be then the time for a quick wrap-up. So as an introduction, why acoustic simulation for heavy equipment? The acoustic simulation can help manufacturers to fit more and more stringent standards, especially for exterior noise, and sells more silent products for the comfort of drivers and of the person that operates on a machine. The fact is that the acoustic comfort is something in which those who buy tractors, for example, are more and more interested in, because it can lead users to hearing problems, contributes to the fatigue, and can be a danger also because they can have difficulties for communicating with other operators. Regular use of the simulation in the development cycle leads to reduced costs at the development time. It can give manufacturers a real competitive advantage compared to their competitors, giving that 50% of best-in-class companies use systematically the simulation to realize their products. So standards regulate noise emission outside as inside the vehicle for vehicles in movement or stationary. These norms are ever more restrictive, as it is illustrated by the histogram about the authorized pass-by noise at the top. In fact, figures are from the automotive industry, but the same noise reduction slope is applied to the heavy equipment industry. The authorized noise level depends on the country or the region, and it is, for example, far more restrictive in Europe than in India. What can be a real issue while India manufacturers want to sell their products on the European market. We have good experience at FFT for simulating the pass-by noise, and for having a concrete example of standards, we can talk about the international ISO standard 7216. These standards define that the exterior noise of a tractor in motion and unladen is limited to 89 dB above 1.5 tons. There is also a standard for the noise inside the tractor cabin that is limited to 86 dB at the constant speed of 7.5 km per hour. So just one word about the software Actran. Actran is a software suite for performing acoustic simulations and is developed by Restrictive Technologies, FFT in short, which is the acoustic business unit of MSC. About Actran, our software, it is a very general purpose acoustic tool that can be used to address various physical problems, but all in one unique method, the finite element method. Several Actran modules allow to unlock the capacity for addressing more complex physics, but it is only a commercial view of Actran, because it is in fact only one unique tool. So the backbone of our solution is Actran Acoustics for studying the acoustic wave propagation inside the fluid, then for taking into account structural components implied in the noise generation. It is necessary to update Actran with the module Vibroacoustics. And for addressing trim car body, the module Actran for trim car body combines the best of the two worlds, your favorite structural tool and Actran. Actran also gets all required physics for studying flow-induced noise with its module Actran Aeroacoustics. And finally, Actran TM and DGM are mainly focused on representing the noise source of aircraft engines, but Actran DGM is also very adapted for studying the sound radiation with very large domains. So that sums up the physical problems that can be tackled with Actran. Of course, a graphical user interface, Actran VI, allows to perform the simulation very easily. So Actran has significant assets for improving the acoustic simulation efficiency. It starts with the pre-processing, thanks to a dedicated GUI, the automatic meshing, and the scripting ability that allows to automate the entire process from the pre-processing to the post-processing. Then, for fastest calculations, Actran offers advanced symmetric boundary condition and distributed computations with parallelism and multi-threading. Finally, about the post-processing, Actran gives a direct access to acoustic indicators like the radiated power, the dissipated power in each layer of a multi-layer material, or the transmission loss. The software also displays results in classic units used in the industry like dB, dBA, per octave band, and gives a global noise value, the OASPL. So, and scripting capabilities in Actran can also be used for automating the whole process. Our CEO, Jean-Louis Migeot, has been interviewed by the SAE Off-Highway magazine. In this article, he explains that Actran is adapted for studying the noise radiated by agricultural and turf machineries. So several noise sources are discussed in this interview, and I will merely speak about these sources in the next part of this presentation. So now we are going to get a look to noise sources and how to reduce them. Then, for illustrating capabilities of the acoustic simulation with Actran, there are some examples taken from the real world. All examples are not taken from the heavy machinery, heavy equipment market, but it corresponds to similar acoustic issues. There are examples from American companies like John Deere and Tenneco, but also from Hyundai in Korea and others also. So what are the noise sources? Well, whether it is a tractor or an excavator, a combine or a lawn mower, noise sources can be ordered in 4 categories. Noise from the powertrain, with the gearbox, the engine, the compressor, and hydraulic pump. Another very important source of noise comes from equipment with fan, which includes cooling fan, HVAC, and turbocharger. The noise from engines, gearbox, and cooling fan increases with the increasing power, and the engine cooling fan is also it's often a dominant noise source for construction in agricultural machineries. Another important noise source is the one coming from the air intake and the exhaust. It can be a more significant source than the engine for the noise outside the vehicle, namely the pass-by noise. Finally, like said previously, the acoustic comfort inside the cabin is something more and more requested, and other sources can have an effect on the noise perceived at the driver's ears. So, about the powertrain noise, this latter is due to the structural vibration and vibration also of different components. It can be reduced by adding covers and stiffness, as by modifying materials' properties and the structure shape. Actran can be used for predicting the noise radiated in far field, namely far from the source. And our software will also allow manufacturers to compute the contribution of different parts of the engine to the radiated noise, as illustrated by the pictures at the bottom on the left, at a given frequency. On this picture, the color of the gearbox indicates in dB the noise contribution, red surfaces being those that radiate the most. The efficiency of acoustic treatments can easily be evaluated with Actran. So Actran is adapted for understanding where the noise comes from and how to reduce it efficiently. Moreover, vibrations computed previously by an external software can be read as acoustic sources in Actran. The hydraulic noise can also be addressed, and it is possible to hear the simulated noise. Pictures and animation on the right show examples of vibrations computed by Adams Flex or Astra, and then read by Actran for computing quickly the radiated noise. Since the last release, Actran 15, an automatic meshing can be performed for any radiating component. It is really easy now to perform acoustic radiations, but it is also really efficient because several meshes are automatically generated for different frequency ranges. So let's see now an industrial example. The first one comes from Mazda. It's a manifold. So the challenge of Mazda was to reduce both the weight and the noise of the manifold. And in fact, a new resin material allowed Mazda engineers to reduce the weight, but it decreased acoustic performances. With Actran, you can use vibrations computed by an SAE software, Actran in this case, for predicting radiating noise and the contribution of several engine parts to this radiating noise. So there is good correlation with experiments that can be seen on the graph on the right. And so with Actran, Mazda succeeded in achieving its challenge, reducing the weight and reducing the noise. So with Actran, you can compute the acoustic radiation also of very large engine. This example is a ship engine, 4-meter-long engine. It has also been computed by Actran, by coupling Actran with a structural code. Before performing the simulation, one can define several zones on the engine, and then, as a result, you can get the contribution of different parts of the engine to the radiating noise as a function of frequency, with, for example, a graph like the one you can see at the bottom. So this is the noise computed and calculated by Actran for this piston slap noise. So in this case, ADAMS is used for the dynamic and the finite elements modeling. Vibrations are thus computed on the cylinder block and reused by Actran for predicting the radiating noise. For computing the radiating noise, Actran has just to be added at the end of the simulation chain, reusing FEA or MBD simulations performed previously. To top it all off, it's possible to listen to the simulated noise as you can hear it. So the next case studies comes from Renault. Renault has recently studied the noise emitted by an electric engine and has published its work at the last SAE conference in 2014. The fact is that noise and vibration requirements have to be guaranteed before the physical prototyping. Therefore, Renault has performed a virtual prototyping by using both Actran and Actran. At the end, Actran outputs the graph on the right. It is a waterfall diagram that shows the engine orders, and Actran can now, in addition to this graph, displays automatically the noise for each of these orders as a function of frequency. What we call at FFT the automatic order tracking. So now let's talk about the noise coming from air intake and exhaust. It can be due to pipe resonance, shell vibrations, or flow turbulences. This noise can be reduced by optimizing the duct shape, the muffler design, and by adding acoustic treatments. Actran will allow exhaust and intake manufacturers to evaluate very quickly the acoustic transmission loss by taking into account perforated plates, porous materials, as flow and temperature gradients. Indeed, the flow inside a muffler can impact significantly transmission losses, as shown on a picture at the top, with the temperature effect. Shells can also be modeled, and their vibrations can come from structural excitation as well as from flow turbulences and duct modes. On the other hand, the TMM method implemented in Actran, TMM standing for Transfer Matrix Method, can be used to split an exhaust line into several parts, each of them being computing separately, which allows modifying the design of only one part and then recombining very quickly the results. The engine can be defined as a noise source also, using data computed by 1D external software like GT Power. This source can be the reflection factor, the mode amplitude, the pressure, or the velocity. Finally, unsteady CFD can be read by Actran for computing and propagating the noise due to turbulences. So let's see now an industrial case study. This first one comes from Tenneco. It's a truck muffler. So basic muffler and exhaust simulations use 1D tool, like GT Power, for computing the noise coming from the engine until the end of the exhaust line. Actran can reuse 1D data that represents the noise source coming from the engine for doing better, taking into account large and complex geometries. What can be done by a 1D tool? So in this next example from Mitsubishi Motors, it's a whole exhaust line. For improving the efficiency of acoustic simulations, Actran can be used for simulating separately several parts of an exhaust line with the TMM method. Design of some of them can be changed at the order of assembly, and final results are very quickly recombined. Also, all the surrounding environment around the exhaust can be taken into account, like you can see at the pictures at the bottom right. So we have already addressed the noise coming from the powertrain, the intake and the exhaust. Now I'm going to talk about equipment with fan. Equipment with fan, like cooling fans or HVAC, make also a lot of noise. The fan noise is far more important for a tractor or an excavator than for a car, because engines are bigger, first, and then vehicles are slow or stationary. So the range is very low, and the fan has a more important role for cooling the engine, and is thus bigger and produces more noise. The noise can come from the blade passage or flow turbulences, which produce respectively a tonal and a broadband contribution. But speaking of a turbocharger, the noise comes from structure vibrations and not only from the turbine. Acoustic emission can be reduced by adding acoustic treatments, optimizing the blades and the duct shape, or by modifying the structure. Manufacturers of this kind of equipment can use Actran for predicting all aeroacoustic noise, whether it is a tonal or a broadband noise, broadband contribution, or even both of them. The noise in far field can be computed with Actran by taking into account the real environment surrounding the source. Moreover, the structural vibrations due to the flow-induced noise can be computed. It is also possible to model accurately acoustic treatments in Actran, and their efficiency is directly computed by our software. So let's see now some industrial case studies. The first one is from Visteon. It's an air conditioning system. This industrial case underlines that Actran can be coupled with a CFD tool for computing the flow-induced noise and getting good correlations with experiments. So the sounds measured and the sounds simulated can be compared merely by listening to them. Next example is from John Deere. It's a cooling fan, an engine cooling fan. In construction and agricultural machineries, engines are very powerful, up to 600 horsepower, and vehicles being slow or stationary, huge cooling fans are required. For computing the noise, Actran used data from an unsteady CFD, and very good correlation of experiments has been obtained. Another example from John Deere, it's a lawn mower. In turf care and in turf care equipment, the dominant noise comes from the cutting blades. The noise of a mower can be simulated as it has been performed for cooling fan and HVAC, using results coming from an unsteady CFD for computing and propagating the flow-induced noise. Now talking about a turbocharger coming from BorgWarner. Actran is added in this case at the end of the simulation chain, which uses first Adams and then Actran for computing the radiating noise. Therefore, the whistling noise of the turbocharger can be predicted at the early development phase. So several designs have been tested, and you can also see at the bottom that a waterfall diagram is shown with engine orders. So to conclude on noise sources, I will talk now about cabin noise. This part of the machine is very important for acoustic comfort inside the vehicle. The problem is merely the same than for a car with similar cabin volumes. In fact, the noise inside the cabin comes from the structural vibrations transmitted by the carrier or mounting points, with silent block especially for construction machinery. But the noise produced by exterior sources has also a huge impact on the noise perceived by the driver. These sources can be simulated with Actran. It is the engine, the cooling fan, the intake and the exhaust noise. And it is possible to get the effect inside the cabin. This noise can be reduced by using trim components and more insulating panels and windows. So let's see now some, I will see examples a bit later. Just one word. Actran is very adapted for modeling the structure-borne noise and trim components. The panel insulation can be evaluated with the transmission loss, but also with the dissipated acoustic energy that is given for each layer of the panel. Structural vibrations of the cabin can be imported in Actran from an external structural code. The other possibility is to load the Actran cabin model with an acoustic pressure field computed by Actran, tending for the pressure field on the cabin due to the exhaust, for example. Porous materials impedance can also be added to the Actran model with the Actran PEM feature. So now, an industrial case. This comes from Nissan. It's a trim vehicle body. First, Actran is used for computing the noise emitted by the exhaust. Then, the acoustic pressure on the car body is applied on the structural model, which is in this case modeled in Actran. And trim components are taken into account for predicting the noise that could be heard by the driver. In this case, the noise source is the exhaust, but it could also be the vibrations of the car body. So let's see another example from Hyundai motor company. It's about road noise on a trim body. So all of these noises, of which I have just talked about, are measured into several conditions. These measurements are covered by international ISO standards, and it can be noticed that if tests are only performed on stationary vehicles or construction machineries, they are also realized in movement. In this case of Hyundai motor company, the road noise has been evaluated inside the cabin by coupling Actran and Actran, including trim components, and the airborne and the structure-borne noise were studied. So yes, about acoustic standards. So there is acoustic standards for construction and for agricultural machineries in static or in dynamic condition. And it is interesting to see that some of the standards are only for a marketing advantage, but others are required for the market authorization. So it is therefore very interesting to compute the noise as specified in the standards, whether it is outside or inside the vehicle. For the measurements of machine noise, the Actran graphical interface allows to set automatically virtual microphones as specified in the standards ISO 3755. Oh no, it's 3744, sorry. So the simulations are performed in the same way than in experiments, and comparisons of results are thus easier. Now taking the example of the pass-by noise covered by the ISO standard 7216, the tractor is driven on 20 meters with two microphones located halfway 7 meters away from the tractor or the combine. In the simulation, the vehicle can be modeled in Actran, and a line of virtual microphones allow computing the noise in the same condition than during experiments. By looking more accurately at the drive-by noise, it appears that different sources can contribute to that exterior noise. The engine, the exhaust, and the cooling fan, for example. But the intake noise can also be more important than the one coming from the engine. As you can see on this animation. Actran can compute the noise of these different sources and evaluate the importance of each of them as a function of frequency. It also allows understanding where the noise comes from and evaluating quickly the efficiency of a new design, whether it is for the comfort or for a market authorization. So to conclude, with Actran, it is a tool that allows you to do a cheap and fast product development with less prototypes and reducing a potential pain of troubleshooting close to the product delivery. Actran also allows to increase acoustic performances of your products by what is a competitive advantage when you have to improve the acoustic comfort, and it is also very important to comply with international or local standards. With Actran, you can also get reliable acoustic simulations with good correlation with tests and to be full confident to try out new designs. So thank you very much for your listening.